Finding the inverse. When you find the inverse, you have to know what the range of the function is, because the range will become the domain of the inverse. So for the square root of 2x plus 1, we need to know the range of that. So square root functions look kind of like that. And the parent function starts at 0, 0. Close. There. Parent function starts at 0, 0. This, from the parent function, though, is shifted. Since there's a plus 1, it's going to shift a little bit to the left. And there's nothing outside the square root adding or subtracting that would shift it up or down. So when we look at this and we look at the range goes from 0 to infinity. The range is 0 to infinity. Now that we know the restriction, the range is going to be the restriction on it. Now we're going to do the algebra steps where we switch x and y. So we're going to say x equals square root 2y plus 1. And now we got to solve it for y. So get rid of the square root by squaring. Get rid of the 1 by subtracting. And then since that's 2y, now we divide everything by 2. So there's our inverse function. X squared minus 1 all over 2. And it has a restriction of from 0 to infinity. So you have to say x is greater than or equal to 0. That's the inverse, f inverse. So you switch x and y and you do all of that. But you have to remember the restriction comes from the range. So we stretch it, find the range, that's our restriction. All right, box problem. When you're writing the polynomial, remember, since we start with a rectangle, and remember you got to cut a little square out of each corner, cutting x off of each corner. So since this is a 22 by 40, 22 by 40, we're going to subtract x from both sides because you cut it off of both sides. So our volume equation, it's got a length and width of 40 minus 2x, and then 22 minus 2x because you cut it from both sides. And then the height of that box, once we cut those squares out of the corners, that x becomes the height where we fold it up. So there's our volume of box. So we're going to take that formula, we're going to graph it. We need to set our domain and range. We got to set our window for this box. So since the dimensions are 22 by 40, the most that you can cut, x would have to be less than half of the smaller one because you have to cut it from both sides. So smaller dimension is 22, so that means it'll be 11 from each side. So our kind of our domain for this would be from 0 to 11. So on our calculator, we're going to graph this. So our dimensions were 40 and 22. So 40 minus 2x (22). And then x. Write out the whole equation. And we'll draw it, but we got to fix our window. So we go to V window. We said our x's can be from 0 through 11, half of the smaller dimension. We don't need to set the y's because we can do zoom auto y set once you have the x set. So there's our graph. So it wants to know when it has a volume of 1680. So we want to know when that volume equals 1680. So that's a G solve. 1680 is the y, so that's an x calc. Y is 1680. And we're going to get two answers, 3.213 and 6. So that's what it's asking for part B. What are the possible values of x? 3.213 and 6. Now, with those values, we have length, width, and height. Length, width, and height. This is like length, this is like width, and this would be like height. So x is 3.213 and 6. That's like our height. Now, the easy one is 6. If x is 6, then our dimensions are 22 minus 2x. So 22 minus 12, that's 10. And 40 minus 2x, so that's 40 minus 12 is 28. That one's easy. Plugging in 3.213 is harder. So the shortcut, the trick for this is if you keep your graph set on that 3.213 and then go to your main menu calculator. Now when you do 40, or if you just type in x, I'll demonstrate that first. You just type in x, it's going to do the 3.213. You don't need to remember it, you just have to type x. So 40 minus 2x, that's your first dimension, 33.574. And then the other dimension is going to be 22 minus 2x. And you can just type that in also, and it'll do the math for you. 15.574. So those are our two sets of dimensions. That would give us a volume of 1680. If you multiplied those numbers together, length times width times height, you'd get 1680 or very close to it because of rounding. A concentration problem. So with these, I always set them up with these little boxes first. You're mixing two things together to get your final result, which is going to have whatever our concentration is. The two things we are mixing together is 10% and 90%. It says we already have 150 liters of 10%, so that's 150 of that one. We're adding X liters of the 90%. We're going to end up with whatever percentage we end up with. But when you add those two things together, the total amount we have will be 150 plus X, and that creates your equation. C times 150 plus X equals 0.1 times 150 plus 0.9 times X. And then get C by itself, so divide. So there's our equation. C of x equals and we'll graph that. We're going to type that into our calculator. So back to our graph. This calculator makes it a little bit easier because it actually does fractions. 0.1 times 150 plus 0.9x. If your calculator does not do fractions, you just need to make sure you have parentheses around the entire numerator and then your divide button or the fraction button, where you need parentheses around the whole thing, like this. And then our denominator was 150 plus x. And we can hit graph on that, but we need to set our window. So as we set this up, we're going to graph this. This will have a horizontal asymptote at 0.9 because you take the coefficients of x. So 0.9 over 1 is going to have a horizontal asymptote, 0.9. It's going to have a y-intercept of 0.1 because when you plug in 0, that's what you get. It's 0.1. And it's going to look like a rational function going towards the asymptote. And the fountain is going to be filled up when it has a total of 1,700 liters, but it started with 150 liters in it. So we got to subtract 150 from that, which means it will be full when we have added 1,550 liters. That's when it will be full. You can't add anything more than that. So we know everything now about this graph. We've set up our window. X is 0 to 1550. Our y's also from that. You could do a zoom auto, but we also know our y's just by looking at it. It goes from like 0 to or 0.1 to 0.9. You can do 0 to 0.9, whatever you want to do with that. So there's our graph, just like what we sketched. And we want G-solve. We want to know the y value when it's filled up, which is an x calc. No, a y calc, because we know the x value. We know the x value, we want to know the y, so we hit x, y calc, because we know the x. And we plug in the 1150, oh, 1550. So we get our final percent there, 82.9%. Keep a decimal, just so I know that you're precise with it. 82.9%. That's the highest percent that it reaches as you fill it up. When it's filled up, it's 82.9. All right, domain. With domain, you're looking at what's not allowed. This is kind of a college algebra review question. Inside a square root, you're not allowed to have negatives. So you take the inside of the square root, x squared minus 9. That's not allowed to be negative. It has to be greater than or equal to 0. So we know it will equal 0 because we can factor this. We know it equals 0 when x equals -3 and x equals +3. But thinking back to college algebra, when you've done these things before, when you have a quadratic inequality, I always picture the graph. This is a parabola. Positive x squared is going to go like that. And it's going to have x-intercepts from what we just found at -3 and +3. We're looking for when it is greater than 0. This line, this x-axis, is 0. It's greater than 0 when it's above. So from college algebra, we solved these a bunch of times. It's everything before you reach -3, and then everything again after you reach +3. In between, it would be less than, but on the two arrow sides here, it's greater than. So you're going to write it out as an interval from -infinity to -3. Is or equal to, so it's going to get a bracket. And then union or equal to, so bracket on the 3 to +infinity. It's above 0, it's above the x-axis here and here. The left of -3 and to the right of +3. All right, graphing our rational function. To get asymptotes or holes, it specifically asks for holes here, so make sure that you are factoring everything and canceling out, because that's where holes happen. Factor the top, you get x times x plus 5. Factor the denominator, you get x plus 5 and x minus 1. X plus 5's cancel. So that means there's a hole when x is -5. And we plug in -5 to the rest of it to get the y coordinate of that hole. So that's going to be -5 over -5 minus 1. -5 over -6 would be +5. The part that do cancel out in the denominator, that's our vertical asymptote, x equals 1. Horizontal asymptotes, you can do from the beginning. You take the coefficients of the biggest degree. So 1x squared over 1x squared is 1. And we can get x-intercepts also if we look at the numerator. We're going to have an x-intercept at 0 because the numerator equals 0 at 0. So we can plot that too. We have an x-intercept of 0. We have a vertical asymptote at 1 and a horizontal asymptote at 1. Vertical asymptote at 1, horizontal asymptote at 1. We know there's a hole at -5, 5, 6. Let's draw that in there. -5, 5, 6 would be like over there. And our graph has to pass through and go with the asymptotes. Passes through 0, 0, passes through that hole, goes with the asymptotes. You could plug in some numbers over here as well. If you plug in 2, you're going to get 2. And your graph's going to look like that. This last one's very similar to the 2 problems ago, finding the domain. We know we cannot have negatives inside the square root. We also know that we cannot have zeros in the denominator. So this x squared minus 4 has to be greater than or equal to 0. But if it's equal to 0, we'd have a 0 in the denominator. So we can't have a 0 in the denominator, so we get rid of the equal to 0. Solve this out. Again, this is a parabola that opens up. It's going to pass through the x-axis at -2 and +2 because that's how it factors. Passes through at -2 and +2. And We're looking for greater than, which is again above the x-axis. So that's everything left of -2, right of +2, this time without the brackets. So it's negative infinity to -2 parentheses, 2 to infinity, also in parentheses.